This is problem number 5, chapter 6, homework 3, and our problem reads the integral of x squared cosine of x dx. And again, in any integral, you want to approach it and see, wait, do I just know what this integral is? This one, I don't think you do. Second approach is, could I try a u du substitution? You can experiment with that a little bit. There are no good u's that would work in this problem. And so then kind of you come to your third option, which is integration by parts or tabular integration. We always come to our acronym for our choosing our u, which then leads to our dv in these problems. And our acronym that we use is Lipit, L for log, I for inverse trig. Don't see either one of those in there. But we do see a polynomial. And our polynomial is x squared. And so we're going to let our u equal x squared. Because we've come down to a polynomial times a trig function, it would also be true for polynomial times exponential functions. Instead of integration by parts, which we'll end up doing, 2 steps, instead we'll opt for, let's do tabular integration. It's the same process, it's just a different way of organizing our thoughts. So my left-hand column is x squared, my right-hand column is cosine x. I know on the left, I'm taking derivatives, because if that was my u, I would take the derivative to find du. On the right-hand column, I'm taking integrals, because if that was my dv, I'd integrate to come up with v. So I'll come down, start in the left column, x squared, the derivative is 2x, the derivative of 2x is 2, the derivative of 2 is 0. Right column, I'm taking integrals. So the plus or minus signs are very important here. And the integral of cosine is sine. The integral of sine is negative cosine. And the integral of negative cosine is negative sine. And you think, well, I've got most of this, those little signs don't matter. If it was a multiple choice test, you can almost bet the College Board is going to mess around with those signs and switch a negative around or something. So if you're not sure, you want to be sure of those signs. Then the last thing we do is remember these alternate because of our formula, which was the integral of u dv equals uv minus the integral of v du. That minus sign makes every other term the opposite. So we alternate our signs, and then we just come across, and we see our answer right there. Those are the products. As I multiply across, I've got my x squared times my sine of x. So I've got x squared sine of x. Then I've got a negative 2x times a negative cosine. So a plus 2x cosine of x. I didn't leave myself quite enough space there, did I? I've got a 2 and a negative sine of x. So minus 2 sine of x. And don't forget plus c. That takes care of problem number 5.